So in this video lesson, we're going to start the process of talking about equations, their solutions. We're going to start with, as it says, solving these kinds of equations through mental math. But before we get there, we have to take a brief step back at expressions and review what expressions are, because expressions and equations are linked very significantly. And we had two different types of expressions when we looked at them. We had numerical expressions and variable expressions. And as a matter of quick review, numerical expressions just had numbers, and they had operations. So things like 3 plus 4 times 5 would be an example of a numerical expression. Whereas a variable expression also had numbers, operations, but then also, because its name was, after all, or is rather, variable expression, it also has variables. So things like x plus 7, 4y minus 5. Things like that are all examples of variable expressions. And variable expressions, as we talked about, we could use to represent a number of different things. But what if what we're really after with our variable expression is a specific value for this variable? We want to know a specific value for x. Now, if we just have an expression, say in this case x plus 9, we can really use any value for x that we want. So let's take this over here. We can really use any value that we want. We can say that x, let's create a chart here, x is 5. Then when we substitute that into the variable expression, we get 5 plus 9 and get that answer to be 14. Say we decide that x needs to be 12. 12 plus 9 is equal to 21. So this is all well and good and helps us if we have the freedom to choose what x is. But what if we're looking for a specific value of x? What if we want to know that specific value for x that makes this expression x plus 9 equal to, say, 25? Not that x is equal to 25, but x plus 9 becomes 25. And in that case, we have to move beyond the idea of just an expression and move to the idea of what's called an equation. And the primary difference between an expression and an equation lies in this symbol right here, one that you're very familiar with, the equal sign. Now you can see in the word equation, we have the root equal or equate, which is also from the root word equal. So seeing that that root is in the word should give you an indication that it has something to do with an equal sign. And when we get down to what an equation really is and how we define an equation, in the equations that you've seen before, you've seen something like 3 plus 5 equals 8. Now in this case, we have 3 plus 5, which is a variable expression, or excuse me, a numerical expression. We have 8, which even though it's just one word and doesn't include any particular operations, is actually also a numerical expression. So two expressions linked with an equal sign. And it turns out that that is exactly what an equation is. When you set two expressions, like we did before, 3 plus 5 is equal to 8, when you set them equal to each other, and that relationship is true, then it becomes an equation, where one singular half of that, 3 plus 5, is an expression. What you get when we set both expressions equal to each other and use the entire set, two expressions set equal to each other, we get an equation. So let's go back then and look at that expression that we were looking for. X plus 9. We used in the example before that perhaps we wanted x plus 9 to be 25. Well, in this case, let's say we wanted x plus 9 to end up being 18. Now, in that case, the x plus 9 expression is helpful in that we know that that's where our variable is going to be. But really, what we're after is this equation. We want our expression x plus 9 to be equal to 18. And so now when we're looking at this, we think to ourselves, what value do we need for x so that x plus 9 is equal to 18? Something along the lines of, what does x need to be? Because there's only one value for x that will make this true. Only one value that when added to 9 becomes 18. And now looking at this, you may have figured it out in your head already. If you haven't, take a second here. I'll pause in the video. You don't have to pause the video, but see if you can think to yourself, working a little bit backwards through this. If x plus 9 equals 18, what does x need to be? So hopefully by now you've thought to yourself, what plus 9 equals 18, and recognized from your math facts that, in fact, the only way that this is true is that if x itself is equal to 9. And so I want to look at the equal signs in both of these equations at this point. X plus 9 equals 18, and x is equal to 9. Now, in the x is equal to 9 equation that I showed here, this equal sign, we're used to seeing this as a solution. This is what shows us what the answer to our problem is that we were looking at. But really, when we're looking at the equal sign in the equation x plus 9 equals 18, that equal sign really doesn't work to, say, represent the solution, because we don't have an easy solution to it. We can work in our head to figure out what x plus 9 is equal to. We don't have an easy way of saying this is the solution because there's an equal sign. Rather, this equal sign just represents the fact that these two parts are the same. This equal sign represents a relationship between the two halves of the equation. It's a relationship that says that x plus 9 and 18 must be exactly the same. And that relationship is marked with an equal sign. So let's take a look at a few more equations real quick. We'll walk through them before we get to the equations that you need to solve as the problems at the end of the video. But I want to look at two more here just so we can go through and keep going through the thinking of how to solve an equation using mental math. The first one I'm going to look at is 5 times n is equal to 40. Now in this case, we can imagine a context like we have 5 boxes of soda cans, let's say. And in each box, or rather in the entire set of boxes, we have 40. So in this case, the equal sign is relating to us the fact that in the total of the 5 boxes, we have 40 soda cans. And we want to know how many are in each box if they're distributed equally. So we have 5n, which represents, again, 5 times n. I'll put a dot there so we can see that. And 40. Now we want to think to ourselves, what times 5 has to be equal to 40? Now if we work backwards through that, we can start to think, well, if something times 5 is equal to 40, maybe we should just divide by 5 and that will give us our answer. And that is a perfectly fine way of thinking about it. Whether you go through it that way or think this number times 5 equals 40, you should quickly get to the idea that n needs to be equal to 8, because 8 is the only number you can multiply by 5 to get to 40. Similarly, if we have y minus 17 equals 0, we're thinking to ourselves, we have some number y. If we take 17 away from this number, maybe we have a pile of apples. If you take 17 away, there are none left in the pile. So what number of apples had to be in that initial pile? What number, when you take away 17, gives you 0? Well, there is only one number that you can take 17 away from to become 0, and that is if y itself is 17. So using those kinds of thought processes and strategies, go ahead, pause the video, and solve, using mental math, each of the 6 equations you see here. And then when you're done, unpause the video, and we'll go over the answers. So I'm going to label these for the way that we are going to go through them. If you label them differently, that's fine, just as long as you can follow along with what we're doing. I'm going to go left to right, 1, 2, 3, 4, 5, 6. So for number 1, we have 5x is equal to 25. That means that some number times 5 has to be equal to 25. And there's only one number that we can multiply by 5 to get to 25, and that number is just x is equal to 5. For number 2, we are taking some number, x, we are dividing by 7 and we're getting 12, so we think to ourselves, what number divided by 7 is 12? There's only one number that fits into that category, and that is x is equal to 84. Now we're looking at x minus 14 is equal to 6. So some number, going to subtract 14 away from it and end up with 6. Well, the only number that you can take 14 away from to get 6 is 20. For number 4, we have x plus 22 is equal to 40. The only number that we can take 22 away from, or rather add 22 to and get 40, is x is equal to 18. Take a number for number 5, subtract 13 and end up with 19. The only number that works for is 32. And finally, if we have a number multiplied by 12 to get 132, the only number we can multiply by 12 to get 132 is x equals 11. So again, as a quick review, an equation is what we get when we set two expressions equal to each other, so that we can start looking at them and perhaps figure out a specific value for a variable that we're looking for, or use other similar strategies to figure out what the solution to those equations are.